All right, hi everyone, welcome back. In this example, we're going to now do a special type of transportation problem. So remember, just where we are in sort of the grand scheme of things, we have LP or linear programming problems. We then did a special type of linear programming problems called transportation problem. And now we're going to do a special type of transportation problem called an assignment problem. An assignment problem is exactly what it sounds like. We'd like to assign something to some other thing. Now, in this example here on the screen, we're going to assign workers to offices, but you can also imagine assigning computers to jobs or people to tasks. But for any sort of assignment, it turns out you can use the transportation template to do that. Pause the video for a second and read the little problem on the screen just to get a sense of where we're going, and have a spreadsheet and work through this with me as we go along. Okay, we're going to rebuild our transportation template instead of just kind of copying it for the old one. Again, repetition sort of leads to understanding. It's better to build it a bunch of times so you understand where all the pieces go. But here's sort of the situation. Imagine you're in HR right now. A company has 3 new hires, Jones, Smith, and Wilson, and you can send them to any office in Omaha, Dallas, New York, or Miami. So you brought in 3 new recruits. Offices have a need. You can send them anywhere. You can only do 1 candidate per office. You can't send a candidate to 2 different offices. And the costs for the relocation, normally when you get a new job, they pay for you to move a little bit. The relocation costs provided by the firm are here. So Jones to Omaha, for example, would be $800. And your job, what's the goal here, is you want to minimize the cost. You want to minimize the total cost. So compare this. If you have the last example open, you can compare it to what we did last time. Once we had our shipping cost table, we then created a wrapper row and a wrapper column with the supply and with the demand. Pause the video for a second. Think about what the supply would be and think about what the demand would be from our quote-unquote factories or our stores. What will go in these wrapper columns? Ready? Well, it turns out Jones can only supply 1 Jones. So the supply here would actually just be 1. And that's true for Smith and that's true for Wilson. And this is just 1 person, not actually $1. So let me fix that. It's just a number here. So Jones can only send 1 Jones elsewhere. You can't take Jones and split them and send them 2 different places. Same thing for the offices. There's a restriction here, only 1 candidate per office. So the number of people that we're sending to Omaha, the demand would be 1, 1, 1, and 1. This is what makes an assignment problem different than a general transportation problem. This is always true. This is the difference. In an assignment problem, there are no wrapper columns on the cost table. It's assumed to be 1, and since they're always 1, we don't write them. So we actually leave this completely blank. We leave it off. We even turn off all the formatting as we go through. So you're never going to see a wrapper column in an assignment problem. It's implied to be 1. Everything else is then the same. So we take our cost table and we copy it, and this will now become our assignment table. It used to be our shipping table, how many we're going to do. Our assignment table. We have our offices at the top. We have our, workers at the bottom. And now we clear out the middle, and these become our decision variables. Who's going to get sent where? What could happen? You can imagine something like a couple 1s could appear. Well, let me turn off the $ formatting. Let's think about what this means. If you have a row with 2 1s, it means you're sending Jones to both Omaha and to Dallas. So 1 is going to be like a yes, like we send 1 Jones to Omaha, 1 to Dallas, and 0 or blank is like a no. So this obviously is a problem. I can't send Jones to Omaha and Dallas. So how do I prevent this from happening? Well, first off, just like before, I need to keep track of the sum of the row. And this is important now. So my sign, what does it need to be? For this to actually work, I can't have 0. That would mean that Jones doesn't get assigned. I can't have 2. That means Jones is getting assigned to 2 offices. So what can I have? Do single apostrophe equal sign here to get the equal sign. It has to get to 1. Where's that coming from? Each candidate gets assigned an office. You can't just say, welcome to the firm, Jones. We don't have a home for you. It doesn't work that way. So this is what you're after. This is going to be your constraint. And notice how we're setting it up over here on the right. And that's fine. Solver does not care where things go. Only you should care where it matches. So this is obviously no good. So just to keep things sort of as dummy numbers that make a little bit of sense, we can put in some dummy numbers just to make sure the spreadsheet's working. So this idea of adding up across, and these are formulas inside of F11, F12, and F13, I want them all to equal and then exactly 1. You don't need to put the equals 1. We could type this right into Solver, but in the interest of transparency, we're going to write this out. And then, of course, we're going to keep track of our total across the bottom row. Now, what is that going to keep track of? Well, I add up everyone going to Omaha. And this is the constraint now that only one candidate per office. I really want this number. It could be 0, right? I have 3 candidates and 4 offices. That can happen. Someone's not going to get a candidate. But I just want to make sure that this number is less than or equal to 1. You should never have a column with multiple 1s in it. What does that mean? It means I sent Jones to Omaha and I sent Wilson to Omaha. But that's not allowed. Only one candidate per office. So the sign is always going to be less than or equal, and then I'm always just going to type 1. So the only formulas in this table, center it and make it pretty, the only formulas in this table are the usual formulas that we use for the transportation problem, where I sum each column, and then I sum each row inside. Last but not least, add your objective. Here we want to minimize our relocation costs. We will color code this cell gray. And what's this going to be? How do I know how much it's going to cost? Well, think about it. If I send Jones to Omaha, it's going to cost me $800. So to keep track of that, I would multiply $800 by wherever Jones gets sent. If he gets sent to Miami, let's say there's a 0 under Omaha and a 1, then I will want to include the $1,100 relocation cost. So hopefully you see where this is going. This is once again a big sum product of all the costs and the decision variable. The formula text, so you can see the formula, but it's once again a good old sum product. This is a true cost in dollars, so we can format it as such. Now the question is, what's the best way to assign people to these offices, minimizing the total relocation? And the spreadsheet model is ready. Head over to Data, head over to Solver. We're going to set our objective cell, which for me is in B19. We're going to minimize this one. Please don't maximize the relocation cost. We're going to have a whole bunch of variable cells here. Now this is a 4x3 table. And we're going to subject it to the usual constraints. So let's batch upload these things. I want the candidates to be assigned one office. Now this is where I really need the 1 here, because I can certainly come in here and just type 1, although you could also just link it. Either one works. But I want the candidate to equal 1, so F11, F13. And then I want to add another one where I take how many candidates are being sent to each office, total row now instead of the column, and I say I want that to be less than or equal to, and once again I could type 1, or in this case just to be different, I'll highlight across and I hit OK. This should feel familiar. This is all the same. Our setup for the objective function, putting it in Solver, check the box that says the variables can be non-negative, select simplex LP, and hit solve. Solver found a solution. Thank you, Solver. You hit OK. And now we have this solution. And once again, the summary sentence is extremely important. Again, Excel, the computer, will be very good at finding the answer, but it will be very terrible at communicating or explaining the model back to your boss or to a client. So our summary sentence here, what does it mean? Remember, 0 means no and a 1 means yes. We would send Jones, Smith to New York, and Wilson to Omaha for a total relocation of $2,400. Again, I love doing this because I see people still watch it. They say, oh, there's no way that could be the best answer. I say, go find me a better one. And they sit there and they play and they try to do it. And of course they can't. 2,400 is the absolute minimum, the best answer for this relocation. All right, nice little assignment problem. Again, the only big difference, what's missing here are the wrapper columns in the cost table. When you have an assignment problem, you don't need those. You leave those blank. Really do miss them, you can certainly put 1s in there, but it's best practice to leave it off. Great job on this example. I'll see you next time.